All right, this is Mrs. Geifert. This is your station 1 recording. So since I'm not there with you right now, I thought I would go over some examples with you on our worksheet. So the first thing you're going to need to do is make sure you have your name, date, period on both of the papers that you grabbed from the file, and also start with lesson 1. You also want to make sure that you have a calculator handy. So as I do some of these examples with you, I will then ask you or someone at the table to pause this video. I will allow you guys to all work together to finish up the section that I want you to finish, and then you can hit play and come back and review the rest of the lesson. As far as the answers go, make sure that you show all your work and your answers are clear, and I will check them over when I return. If there's any issues, I will bring them to you so you can redo them. All right, let's get started. So if you look here at the first section, we have 4 times ... times 4, okay? And then it says 7 times. Which number do you think is the base? All right, if you said 4, then you are correct. What would be my exponent? The 7. And that's all you have to do for these. What this is showing is that this, writing it in exponential form or exponential notation, allows you to write it as a shortcut. So you don't have to write out 7 4s. And 7 4s wouldn't be too bad, but could you imagine having to write it out 200 times? That's when you want to definitely know that you can write it in exponential form. Let's look at number 2. We have 3.6 ... 3.6, and the dots just means that that was a continuum. Then it says blank times. All right, but look over here where it says equals. It says 3.6 to the 47th power. So how many times was that 3.6 written out? And we would say 47 times. All right, I want someone to pause the video, and you are going to finish up on number 10. All right, so hopefully you all got a chance to finish up to number 10. By the way, number 10, that is an N. I know it looks like an 11 on your paper, but you should have N times right there. Okay, and again, I will check the rest of those when I return. Let's check this one. When it's written in this format, what do we do with our exponents if the bases are the same? Well, hopefully you said add them. So you keep the base, and we're going to add the exponents. So we have 23 plus 8. All right, well, 23 plus 8 is 14. So we're going to leave this in exponential form, especially since that's written in the directions there. So it'll be 14 to the 31st power. All right, if your base is negative, it stays negative. You can have a negative base. You cannot have a negative exponent. If you get a negative exponent, that's when we change its formatting. Okay, go ahead and pause this video and go up to number 17. All right, hopefully everyone at the table had enough time to finish up to 17. Let's look at 18 and 19. If you notice, the bases are all the same. Sometimes you can add 2 exponents, sometimes you can add more than 2. As long as the bases are the same, you can add up those exponents. So we're going to keep the base of 9, and then we're going to say 4 plus 6 plus 13. All right, I'm going to let you go ahead and solve that one, 18 and 19. All right, let's try 22 through 25. Actually, let's try 20 and 21 first. I apologize, I jumped gun. If you notice, 20 and 21 are written a little differently. 20 has two different bases. We have a base of 6 and we have a base of 4. So you're going to combine the bases of 6 together. So that'll be one big 6. And then we're going to add those exponents. So 5 plus 14. Okay? Now let's combine our 4s. And that's going to be times 4. Oops, that's a 4. 9 plus 3. So in the end, you should have the final answer of 6 to the 19th power times 4 to the 12th power. And that's exactly how you leave it. Now, if you look at 21, 21 is different because they threw an equal sign right here in the middle of it. Well, whenever you get an equal sign right in the middle of two equations, that means they want you to see, are they equal? So you're going to solve them both sides. Now, if you notice, both sides have a 2 to the 4th power. So we're going to go ahead and check that and check that. But this one are not the same. We have 8 to the 2nd power and we have 2 to the 6th. What is 8 to the 2nd power? It is 64. So in order for this equation to be equal, 2 to the 6th power also needs to be 64. Go ahead and try that on your calculator. All right, hopefully you got 64 as well. So yes, both of these equations are equal. So the directions say to make sure you write it in the most simplest form. The most simplest form for these is actually this equation right here. The reason that's the most simplest is because that's where the exponents or the exponential notation is in its smallest, simplest form. This one over here had an an exponent of a 6, so that one kind of made it a little bit bigger. So our final answer is 2 to the 4th times 8 squared. All right, now we'll go to 22 through 25. So when we have them written as fractions, we actually keep the base. Whatever the base is, you keep the base right now. If it's positive, it's negative, it's a fraction, it does not matter. Just keep it. All you're working with are the exponents. So we subtract the exponents. This is going to be 9 take away 6, which will give you 7 to the 3rd power. Go ahead and pause this video and stop at 25. All right. Hopefully your table had enough time to get that done. All right, so whenever we raise a power to another power, hopefully you remember what you do. You're going to keep your base, and then you're going to multiply these two. So that's going to be 3 times 9. Okay, so 3 times 9 gives you 15 to the 27th power. All right, go ahead and try 27. 28 is on the back. Do not let the second set of parentheses fool you. Don't, just ignore that. And try 29. And then I will meet you guys for 30. All right, if you are all caught up to 30, this one real quick, I just want to review with you. If the numbers inside the parentheses do not have exponents, just go ahead and multiply those together. You would get 44 to the 9th power. So if you got that as your answer, you did it right. But these whole numbers do have exponents, which means this 5 needs to be multiplied to both exponents on the inside. So for right now, we're just going to keep the base. And we're going to multiply the exponents. So that's going to be 3, and then 2 times 5, times 7, and then 4 times 5. So in the end, we get 3 to the 10th power times 7 to the 20th power. All right. If you have not had a chance to go back and finish any, please make sure you do. You can check answers of the ones I did not do with you with your partners at your table. And then I want you to walk this paper over and do the done and done file. So I have a chance to look it over and grade it. All right. And now let's go ahead and grab lesson 2. So I'm going to pull it up. All right, here's lesson 2. Lesson 2 is all about negative exponents. Again, make sure your name, date, period is on this one. So whenever you have a negative exponent, you need to make it positive. In order to make it positive, you take its reciprocal. So if it's in whole number form, its reciprocal would be to change it into a fraction. So that's going to be 1 over 5 to the third power. And that's as far as we're going today because they do want you to leave this in exponential form. You do not want to multiply out 5 to the third. Just leave it like this. But if you look at number 2, we have 1 over 8 to the ninth power. And you're probably thinking, let me just write it a little bit bigger here. Well, that one's already done. Well, what's its reciprocal? What's its reverse? In other words, what answer did it have in order for it to become a fraction? And that would be 8 to the negative ninth power. All right, go ahead and try up to number 6. And then I'll meet you back for the bottom section. All right, hopefully you had a chance to check up to number 6, but I actually want to do number 6 with you, okay? Because I want to explain what's actually going on here. If you got confused on the wording here of let x be a non-zero number, that just means that when we eventually go to actually solve these out, you don't want x to be a 0. So go ahead and treat it just like a normal variable at this time. But this one here, I'm going to give you the answer, and let's see if any of you got it right. It would be x over y to the fourth power. Now, the reason it's not 1 over xy is because the negative exponent is only attached to the y. In order for it to be attached to the x, there would have been parentheses. This here would have got this as an answer. Okay? But since there were no parentheses, the x is positive. It was the y that was negative. All right, now let's try these. We have 19 to the second divided by 19 to the fifth. So that's going to be 19 and then 2 minus 5. Well, we know that that's going to give me 19 to the negative third power. And therefore, my final answer is 1 over 19 to the third. Now, 8 seems to give kids a hard time. So let me write it out this way for you. We're going to say 17, the base of 17, and then 16, take away negative 3. A lot of students see that negative 3 and they go, oh, great, there's my subtraction symbol already there for me. No, it's still subtract. It's subtracted negative 3. And if you remember, a negative and a negative becomes a positive. So that actually is now 17 base and then 16 plus 3. Final answer would be 17 to the 19th power. And then you're done. All right, so make sure that this one also goes in the done and done file. Check your file and make sure that you are all caught up on your work and check for any redos that may have been placed in your file. And that is the end of this video.